a lesson that we're going to do to talk about another rule in finding derivatives. It's called the chain rule. Now, the chain rule is going to help us when we're trying to find the derivative of a composition of two functions. All right, so we're going to go through some example problems on how to do this. Again, this is one of those things that the more you practice, the more confident you'll be in being able to do these. So make sure you're trying these homework problems, turning them in so I can give you feedback on how it's going, okay? All right, so let's just talk first for how to find the chain rule, or how to use it, I should say. So again, you'll notice the notation for composition, f of g of x. And the way we're going to find that derivative is to find the derivative of the outside function, all right? But we're going to evaluate it with the inside function as our input. And then we're also going to multiply whatever that is times the derivative of our inside function. Okay, so that's ultimately how we're going to do the chain rule. You can look at this kind of table right here, or problem solving strategy. I want to walk you through how to do all this. But there's a couple of things to remember. The first thing to think of is that if you're doing the composition or the derivative of composition of two functions, then there's going to be two things you're going to find. If we're doing it with three functions, then you're going to find three things, and so on and so forth. So hopefully that will always help you. And then we're never going to evaluate a derivative at a derivative. All right, so we're only going to evaluate derivatives at functions. Okay, this last thing, the power rule, is just kind of going with something that we did in one of our first, or I guess I should say lesson 3.3 when we talked about the power rule, but it's a little different when your inside function is also a function. So we're going to have to then multiply by the derivative of that inside function. All right, I think that will be a little bit easier just because you've already worked with a version of the power rule. All right, let's try one. All right, so the first thing I notice is that this is everything is in the denominator and it's raised to the second power. So I'm actually going to rewrite this to be h of x equals 3x squared plus 1 to the negative second power. Okay? Now, when I do that, I can find the derivative of h of x by doing d dx of 3x squared plus 1 to the negative second power. Okay? So how I'm going to do this is I'm going to take that power and I'm going to move it to the front, and then I'm going to rewrite my inside the parentheses function. And remember, when you use the power rule, my new power is the original power minus 1. So negative 2 minus 1 is going to be negative 3. But we're not done, right? The new piece here, using the previous slide, the new piece is that this still needs to multiply by the derivative of that inside function. So by the derivative of 3x squared plus 1. Okay, so that's kind of the new part here. So I'm going to copy this down. So negative 2 times 3x squared plus 1 to the negative third power. And then I'm going to multiply that by the derivative of 3x squared plus 1 is 6x. Okay, so to clean it up, to get my answer, I have h prime of x equals negative 12x, right? Multiplying negative 2 times 6x, negative 12x over 3x squared plus 1 to the positive third power. If you wanted to leave that in the numerator raised to the negative third power, that's fine. It doesn't matter. I don't care. But this is the derivative of h of x. Okay, let's try this one. All right, now this is going to be, I'll be referencing the lesson we did on finding the derivatives of trig functions. So if you want to have those notes available, please have those ready because we are going to be using those. So it says find the derivative of sine cubed of x. So I'm going to rewrite this as h of x equals sine of x cubed. So to find the derivative of h of x, so h prime of x, is d dx of sine of x cubed. Taking the derivative of all of that. Now, following kind of the same procedure that I just did on the previous example, I'm going to take that 3 in the exponent, bring it down. So it's 3 times the sine of x raised to the second power. And then I need to multiply that by the derivative of sine of x. All right? And we know the derivative of sine of x, we did that in the previous lesson, the derivative of sine of x is cosine of x. So this is going to be cosine of x. So if you wanted to clean it up, you could write 3 times sine squared x times cosine x. That is the derivative. All right, let's keep going. Now, we're going to find the equation of a line that's tangent to this graph at x equals 2. We've done this problem now. This is the third time we've done a problem like this in this unit. All right, so hopefully by now you're ready for kind of the order that we do this. We are going to use point-slope form. Okay, we are going to use this form, which is y minus y sub 1 equals m times x minus x sub 1. Okay, so in order to use point-slope form, as I've said many times, you must have a point and you must have a slope. Well, we have part of the point. They're telling us the x value for our point is 2. So to find the y value, I'm going to plug in 2 to this original function. So 3 times 2 minus 5 squared. That's going to be 1 over. So 3 times 2 is 6. 6 minus 5 is 1. 1 squared is 1. So that's equal to 1. So my point is 2, 1. So this is my point. All right, now to find the slope, I need to find the derivative of this function h of x. And then I'm going to plug in 2 to that derivative to find the slope of the tangent line to this graph at that exact point. So let's first rewrite h of x. I'm going to write it as 3x minus 5 to the negative second power. So to find the derivative, I'm going to go d dx of 3x minus 5 to the negative second power. All right, so that's going to be equal to, right, you're going to move the negative 2 in front. So I should put that in parentheses. There we go. Negative 2 in front, then 3x minus 5. Negative 2 minus 1 is negative 3. I'm going to show a little less work here because I know we've been doing it now. This is the third time. Times the derivative of that inside, right? And the derivative of 3x minus 5 is just 3. So the h prime of x, or the derivative of h of x, is negative 6 times 3x minus 5 to the negative third power. Now, if you wanted to, you could rewrite this as I'm going to do here, where you move it to the denominator. You don't have to. You can leave it where that negative 3 is up there. That's fine. You can rewrite it. It's your choice. We do need to plug in our x value, which is 2. So that's a negative 6 over 3 times 2 minus 5 cubed. So negative 6 over 3 times 2 is 6. 6 minus 5 is 1. 1 cubed is 1. So our slope is negative 6. So that is the slope of our tangent line. So now we have a point. We have the slope. We're ready to do our point-slope form. So y minus y sub 1 equals m times x minus x sub 1. So my point is 2, 1. So y minus 1 equals my slope, negative 6 times x minus 2. Distribute the negative 6. So negative 6x plus 12. So the answer is y equals negative 6x plus 13. So that is the equation for our tangent line to this curve at x equals 2. Now, I know that was a lot of algebra, but what I want to do is I want to show you on Desmos, kind of link everything we just did with the graph. Okay? So I'm going to type in, where's Desmos? I'm going to graph the original, which is 1 over 3x minus 5, all of that squared. So 1 over 3x minus 5, all of that squared. Okay, and then I'm going to graph my tangent line, which is negative 6x plus 13. And you can see that the blue line is tangent to this curve that's red at the point x equals 2 at that point. All right, so we did it. All right, I'm going to pause for a second. Okay, sorry about that. Now, let's get back into finding more derivatives with the chain rule. Okay, so this one says find the derivative of h of x if you have that equal to cosine of g of x. So I'm going to find h prime of x, which is going to be the derivative of cosine of g of x. Okay, now here's how we're going to do this. We're going to find the derivative of cosine. All right, so the derivative of cosine is the opposite of sine, but we're going to evaluate that at my inside function, which is g of x. So that's going to be the input for that derivative. And then times, all right, the derivative of my inside function, which is g of x. So the answer here is going to be the opposite of the sine of g of x times g prime of x, right? The derivative of g of x is g prime of x. So this is the answer. All right, let's keep going. Another one where we're using the chain rule with a cosine function. So h prime of x is going to be d dx of the cosine of 5x squared. All right, so again, I'm going to do the derivative of cosine, which is the opposite of sine. All right, but I'm evaluating that at my inside function. So that goes inside, think of that as like your argument, times the derivative of that inside function, 5x squared. So this is the opposite of the sine of 5x squared times the derivative of 5x squared, which is 10x. All right, so to write it a little bit simpler, it's going to be negative 10x times the sine of 5x squared. And that's it. The next slide. All right, we're going to find the derivative of h of x, and this time it's saying to find the secant of 4x to the fifth power plus 2 of x, okay? So the way we're going to do this is we're going to do h prime of x is equal to d dx of the secant of 4x to the fifth power plus 2x. All right, and I know we haven't done this in a while or since last lesson, but I wrote them down here that if you have secant is your trigonometric function, your trig function, the derivative of secant is secant x tangent x. I can go back to the previous lesson if you'd like and go back to that table. All right, here's secant. The derivative of secant x, it's right here, is secant x tangent x. Okay, so I'm going to use that to help me with this problem. So I'm going to do the derivative of secant is secant of x, but again, my x is my inside input here, 4x to the fifth power plus 2x times tangent of that same thing. But I'm not done because I need to multiply all of that by the derivative of that inside function, which is that 4x to the fifth power plus 2x. So I'm going to skip a step of work here. I'll show it when I do it in class. Times the derivative of 4x to the fifth power is 20x to the fourth power and then plus 2. All right. So if I wanted to organize this a little nicer, you could put the stuff that doesn't have any trig functions in front. So 20x to the fourth power plus 2 times secant of 4x to the fifth power plus 2x times tangent of 4x to the fifth power plus 2x. That is the answer. Okay, now this one is where you're going to use the chain rule, but we're also going to use the product rule within it. So it's a combination of a previous rule with this new rule, the chain rule. So the first thing I'm going to do is I'm going to use the product rule, which says to find the derivative of the first function, so 2x plus 1 to the fifth power, times the original second function, 3x minus 2 to the seventh, plus the derivative of the second function, 3x minus 2 to the seventh, times the original first one, 2x plus 1 to the fifth power. Now, when you do this, when you find this derivative, right, we have to use the chain rule because we're finding the derivative of 2x plus 1 to the 5th power. So we move the 5 in front, times 2x plus 1 to the 4th power. And I'm going to skip this step, so hopefully you've been paying attention. This is times the derivative of that inside function, of that 2x plus 1, which is 2, times 3x minus 2 to the 7th power, plus, we're going to do the same thing here, 7 times 3x minus 2 to the 6th power. Don't forget to multiply by the derivative of that inside, which is the derivative of 3x minus 2, which is 3, times 2x plus 1 to the 5th power. So I'm going to clean this up a little bit, but essentially that's the work I'm looking for. All right, so we have 5 times 2 is 10 times 2x plus 1 to the 4th power times 3x minus 2 to the 7th power, plus 7 times 3, which is 21, times 3x minus 2 to the 6th power times 2x plus 1 to the 5th power. That is it. Whew. Okay. Now, the next one is going to be talking about taking the derivative of the composition of 3 or more functions. And this is kind of going back to what I said at the beginning, that when you're using the chain rule, right, the number of compositions should not be more than the number of pieces. All right, so if you have 3, then you should have 3 pieces. So in this example, we're talking about h of f of g of x. So you'll notice that we have 3 pieces, right? Here's one piece, h prime. So the derivative of h evaluated at the inside function, which is actually 2 functions, a composition. Then the second piece, we have the derivative of f, that middle function, evaluated at the most inside function. And then finally, the third piece, the derivative of g prime of x, so the derivative of the most inside. Okay, so that's kind of how you want to view it. If you're doing 3 functions, there